Hello everyone, welcome back to the channel. Today we are going to discuss one of the most important concept in complex analysis, the Cauchy-Riemann equation. These equations provide the foundation for the determining whether the complex function is differentiable and analytic. While the differentiation in ordinary differential calculus involves function of single variable, complex function depend on both real and imaginary components, making the concept much more interesting and powerful. The Cauchy-Riemann equation acts as mathematical that test the Cauchy-Riemann equation act as a mathematical test that connects the real and imaginary parts of the complex function. If these conditions are satisfied, the function behaves smoothly in complex plane and possesses a complex derivative. This idea has a fair reacting application in reaching engineering, physics, fluid dynamics, electrostatics, and conformal mapping. Next, let us see complex function analyticity. Now that we understand the CR equation, let's explore the real world application. There are two different way real part and imaginary part. So it's satisfying the complex Cauchy-Riemann equation u x equal to u vy and vx equal to minus uy. One of the most important application is fluid dynamics. So, the engineer uses analytic function that satisfies Cauchy's Riemann equation to the model the flow of ideal fluids. These functions help describe the velocity and movement of fluids around objects such as aircraft wings, pipelines, and ship hulls, making the analysis of flow patterns much simpler. The another major application is electrostatic and electromagnetic theory. The electrical potential field lines can often be represented using harmonic and analytic function. The Cauchy-Riemann equation ensure the proper relationship between these quantities, allowing engineers and physicists to study electric field efficiency. Here, the fundamental definitions and Cauchy's Riemann equations, theorem and conditions used in polar form or complex form or Cartesian form. In the another one application was the heat transform. The temperature distribution in a two-dimensional region is often governed by harmonic function. Since the analytic function satisfies the Cauchy-Riemann equation, they provide powerful tools for analyzing temperature, flow, and steady-state heat conduction. So the Cauchy-Riemann equation also play a significant role on signal processing control system in and advanced mathematical modeling. They help researchers understand the behavior of complex valued function and ensure a smooth, predictable solution to many engineer problems. Thus, the CR equation are not just theoretical mathematical condition; they serve as essential tool in solving practical problem across the engineering, physics, and applied science. So this is the Cauchy stream CR equation: dou u by dou x equal to dou v by dou y, and dou u by dou x equal to minus dou v by dou x. Here, f of x equal to xy plus iy is continuous everywhere but not differential everywhere, because differentiate into xy. So u is xy and v equal to y. U equal to xy is continuous, v equal to y is also continuous, but f of z equal to u plus iv is also continuous, but CR equation not satisfied, so it cannot differential equation and analytic function. Thank you.